Okay, the next combination is called parallel combination because they are put parallelly to each other, right? The resistors are put in such a way that the potential difference across all of them is same. How? So as you can see, this is the battery, right? This is at V potential, this is at zero potential. There's no resistor anywhere, which means that there's no potential drop because potential drop happens only when there's a resistor, right? There's now no resistance, zero resistance, so no potential drop, which means all these points are at V potential and all these points are connected to zero. This is zero potential, right? This is V potential. So all these points are connected to zero. So all these points are at zero potential. So this is at V potential, this is at zero potential. What's the potential difference? V minus zero, V. This is at V potential, this is at zero potential. What's the potential difference? V minus zero, V. Same here, right? V. So all three resistors have same potential difference, which is V, and hence they are in parallel. As you can see, they're kept parallelly. Okay, so if we are to create a simplified circuit like this, and instead of writing R1, R2, R3 in parallel, we can just say R net, which is an equivalent resistance to these these three. So we can write something like this. Now just write the equation. So I1 R1 is equals to V, I2 R2 is equals to V, I3 R3 equals to V, because that's a potential difference. And here IR is equals to V. Done. And yeah, one more thing. So if the current is coming out like this, these are the number of charged particles which is coming out. So at this point, what will happen? These charged particles will split, right? Which means I1 plus I2 plus I3 is going to be equal to I. So that's it. So let me write all the equations. I1 R1 is equals to V, I2 R2 is equals to V, I3 R3 is equals to V. Is that correct? Okay, and I is equals to I1 plus I2 plus I3. I1 will be equal to V upon R1, right? So I can just write V upon R1 plus I2 will be equal to V upon R2 and I3 will be equal to V upon R3, right? And V equals to I R net. Okay, so I is equals to V upon R net. So instead of I, I'll write V upon R net. Okay, that's it. Cancel V. How would you cancel V? Take V out. So this becomes 1 by R net is equals to take V common. This becomes 1 upon R1 plus 1 upon R2 plus 1 upon R3, right? So V cancel, and then the final formula comes out to be 1 upon R net equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3, right? So what is this R net? This R net is an equivalent resistance, a resistance which is equal to R1, R2, R3 put in parallel, right? So that's the formula. Let's take an example. Suppose there is a resistor of 2 ohms and there is a resistor of 4 ohms kept in parallel, right, to each other. So what will be the R net? So 1 upon R net is equals to 1 upon 2 plus 1 upon 4 is equals to LCM is 4. This is 2 plus 1 equals to 3 by 4. So the answer is 3 by 4 ohms, right? No, that's where most of the people make it wrong. 1 upon R net is 3 by 4, which means R net is equals to 4 upon 3 ohms. So don't make that mistake. Make sure that 1 upon R net, once you find, you have to invert it and you have to find R net, which is equals to 4 by 3 ohms. All right.